you're given f of z equals 3z squared plus z minus 4, where z is used to represent the imaginary number, right? Or is an imaginary function, I should say. Now you must find f of 2 minus 3i, find the real and imaginary part of f of z, and find double prime z. Alright? Now, remember what z represents? Generally, z is equal to the x value minus, I like using j, but they use I here. Or plus, I should say, plus I y. Alright? That's generally what z is. Now, I'm going to ask you to pause the video and write the question down and finish it off. Okay, very well, you have finished. Let's work out the question together now. Here, in this case, f of 2 minus 3i means z is 2 minus 3i, right? So in part 1, f of 2 minus 3i is equal to 3 times z squared, which is 2 minus 3i squared, plus 2 minus 3i minus 4. Okay. Now this is 2, this is 3 times 2 minus 3i multiplied by 2 minus 3i plus 2 minus 3i minus 4. Now it is 3 times, we're going to multiply out the brackets now. 2 times 2 is 4. 2 times negative 3i is minus 6i. Negative 3 times 2 minus 6i. Negative 3 by negative 3 is plus 9i squared. Okay, plus you have, you can open the bracket here, 2 minus 3i minus 4. So what happens here now? This is 3 times 4 minus is going to be 12i. Now remember that the square root I is really the square root of negative 1, right? So in this case it is negative 9 that you have, right? Let's put the minus 3i here, and then the 2 minus 4 is minus 2. So that's a minus 2 there, right? So multiply out the brackets now. 3 4 is 12 minus 3 12 36. Oh, let's not multiply out the brackets yet. Let's simplify them first. 3 times negative 12i. 4 minus 9 is negative 5. So this is a negative 5 minus 3i minus 2. So what you get is equal to negative 36i, 3 5 minus 15 minus 3i minus 2. So you get negative 36 minus 3i. Negative 15 minus 2 is negative 17. Negative 36 minus 3 is minus 39i. So there you go for that part. Alright? Now the real and imaginary part of f of z. Alright, so that's part 2. F of z is equal to 3z squared plus z minus 4. 3z squared plus z minus 4. Let me rewrite this. Minus 4. But the thing is, z is equal to x plus I y. So what you have is f of z is equal to 3 times x plus iy squared plus x plus iy, which is z minus 4. This is 3 times x plus iy times x plus iy plus x plus iy minus 4. Alright? So this is 3 times, you have x squared plus xy, so ixy plus ixy again plus I squared y squared plus x, let me put minus 4 here, plus x minus 4 plus I y. Okay. Now this is going to be 3x squared. Well, this will be 2iy, you know, and 3, 2, 6, so it's plus 6 ixy, I should say. Ixy plus ixy give you 2ixy. And then that multiplied by 3 give you 6ixy. Alright? Plus, alright, it's going to be a minus because this is a negative 1. Negative 1 by 3 is negative 3, y squared. Okay? Plus x minus 4 plus I y. Alright, now let's put the real part and imaginary part separately. It's going to be the real part 3x squared. All of those without the i's are real part. Minus 3y squared plus x minus 4. So real part plus I. Let me put the I first. I 6xy plus I y. So the real part is equal to 3x squared minus 3y squared plus x minus 4. The imaginary part is equal to, well, if you can factorize this, you know, and you get 6x y plus y inside the bracket. So you have the real part and the imaginary part of f of z. Alright. F double prime of z. Now, you want to find out what is f double prime of z. Let's work it out over here. We have f of z is equal to 3z squared plus z minus 4. Now f prime of z, the first derivative of z will be 3 to 6z plus 1. And this differentiate this again to get the second derivative, f double prime of z is equal to 6. This is a 6. Well, that's what I got. 6 there. Okay, so that's it for now. See you in the next video.